now turn our attention to polynomial and rational inequalities, and this first problem is going to be based upon this graph. We want to know, where is the function less than 0? Well, the answer is to the right of 0, the function is down below. So our answer will be from 0 to infinity. Where is the graph less than or equal to 0? Well, now we will include x equals 0, but we also have another point at -2 to include. So we will state that the set is -2 united with the interval from and including the 0 on up to infinity. We now ask, where is the graph above the x-axis? Where is it above 0? Well, it's everything to the left of 0 except at -2 itself. So from -infinity up to -2, union the interval from -2 to 0. When we go to find out where is it greater than or equal to 0, now we can include these two values where it's equal to 0, which basically means we're going to include the right endpoint and fill in this gap here at -2 and have the interval from -infinity up to 0, which we include at that right endpoint. For this next problem, we start with this equation, which is a factorable. X minus 7 times x minus 7 is equal to 0, which basically tells us that x minus 7 is equal to 0 and x equals 7. So our solution set is just the number 7, but that is for the equation. For these next few parts, we're going to be looking at x minus 7 squared less than 0, x minus 7 squared less than or equal to 0, x minus 7 squared greater than 0, and in this fourth case, x minus 7 squared greater than or equal to 0. Now, we know about solving the equation. We've done this. Now we're focusing on the inequalities. And because we're comparing with 0, we're going to look at this in a different way. Notice that a quantity squared is always positive. And when is a positive less than 0? The answer is never. So we have no solution as our solution set. When is it less than or equal to 0? Well, we already know about the less than part, but now we've got the equal to part. The equal to just gives us the answer 7. Where is the function greater than 0? Well, we know x minus 7 squared is positive, and it's equal to 0 at the 7, but everywhere else it's going to be greater than 0. So our solution will be from -infinity up to 7, which we don't include, union the interval to the right of 7 from 7 to infinity. Now, finally, in this last case, all of these values are positive, which is greater than or equal to 0, so we will have all real numbers as our solution set for part E. Here we have another polynomial inequality, but it's not got 0 on the right hand side. So we're going to have to do a little bit of work on this first. The left side is going to remain 5y squared plus 7y, but on the right side we're going to distribute and have 3y plus 12. Since the quadratic term is on the left, we will bring everything from the right over to the left, and we will now have 5y squared. After we subtract 3y, we will have plus 4y minus 12 is less than 0. This will factor into 5y minus 6 times y plus 2 is less than 0. And we're going to have critical values at 6/5 and -2. Now, if this were an equation, on the number line we would have our solutions at -2 and 6/5. But because this is an inequality, our answer will be in the regions to the left, middle, or right, and that's where we've got to do some analysis. We know that the product of these two parentheses must be negative. So let's look at the sign of the parentheses within those intervals. Let's look at the interval 5y minus 6 and y plus 2. When you substitute values less than -2 into 5y minus 6, you get negative values. If you substitute values in the middle, such as 0 into 5y minus 6, you get negative 6, which is negative. And values to the right of 6/5, you will get a positive value. Now let's analyze y plus 2. When you substitute a value to the left of negative 2, you get a negative value. In the center, you get a positive, and to the right, you get a positive. We are interested in the product of these two parentheses, which means for values that we're analyzing in each of these different regions, we want the product. And negative times negative is positive, negative times positive is negative, and positive times positive is positive. Our problem says we are interested in values that are less than 0, meaning that our solution set will be between these two numbers in that central section. And I can write our solution set here as the interval from negative 2 to 6/5.